Lesson 5, Cell Division, the Cell Cycle. Sometimes organisms need to increase cell number. Sometimes they even need to decrease the number of cells. Cell division, two methods of cell division that we will be looking at in this lesson which increase cell number. The first one is mitosis. Mitosis is a nuclear division which occurs in somatic cells. A somatic cell is anything other than the gametes, which are egg and sperm. Mitosis is the nuclear division, and then that is followed by cytokinesis, where the rest of the cell divides. What's important to remember about mitosis is this maintains the chromosome number. A second type of cell division, meiosis, is a nuclear division that reduces the chromosome number, and this occurs to produce gametes, the sperm and the egg. We'll be spending more time looking at both mitosis and meiosis in this lesson. A decrease in cell number is called apoptosis. This is programmed cell death or cell suicide. This is not cell death due to damage or illness or injury, but rather some programming that takes place that results in cells destroying themselves. There are some enzymes found inside cells called caspases, and these are like cellular executioners. Normally they are inhibited, but things can arise, either internal or external signals that cause these cells to activate the caspases, and as a result the cells will let go of their neighbors. They become kind of round like a blimp. They begin to chop up their DNA, and then the cell fragments. This occurs sometimes during development. There are times in development when cells need to be destroyed. Also, there are cases where cells can become damaged. They can have damaged DNA mutations, and as a result, these cells receive the signal to kill themselves. Here is an example of where apoptosis did and did not occur. During development, there is a web of skin between the digits, and apoptosis eliminates that webbing so that we have free fingers and toes. And you can see here in the middle, this individual has two toes that still have the webbing, where apoptosis did not occur. This is a diagram of the cell cycle, the life and times of a cell. A non-dividing cell is in interphase. And so if you look at the diagram, the big purple arc represents interphase. This is a non-dividing cell. So a cell spends most of its life in interphase. Now we can subdivide interphase. First is G1. What happens in G1 is cellular growth. This is a brand new baby cell that begins its life in G1, and so all of its organelles are replicated, and then the cell can move from G1 into the S stage. What happens in S is some continued growth, but primarily S is when the DNA is replicated. Following S, the cell can move into G2. G2 is some additional growth and preparation for cell division. So then down at the bottom is cell division. And so in this diagram, this is represents mitosis, or the M phase. So mitosis is nuclear division. It's divided into several stages. We'll be looking at these stages individually, and then cytokinesis divides the rest of the cell. So one cell divides. We have two daughters. Each of these is going to begin G1 of interphase. Up at the top I have noted something called G0. There are some cell types that will not divide after our own fetal development. Neurons, for the most part, will not divide, and so they complete G1, and then they exit the cell cycle, and they spend the remainder of their life in G0. So not all cell types stay on the treadmill. We have some cells, like epithelial cells, which may constantly divide, but there are others that can exit the cell cycle into this G0 and they will never divide.